Assalamu alaikum everyone. So today's lesson is going to be on R programming. So firstly, let's go ahead and download this R program. So I'm using a Windows laptop, so I will be downloading from Windows. For macOS, you can refer to YouTube if you're having any kind of issues. So this website is from the slides, or you can just search R programming. From here, you can go to the second website, which is what is R. All right. And here you can go to download, see, right? And then you can choose the server website. So I'm going to use Zero Cloud. Okay, so here we came back to this website, like this one. So we can download R for Windows, and then we will install R for the first time. Download R 4.4.1. All right, so I'm downloading. Okay, it's downloaded now. Let's install this. First, English on. You can follow through the instructions. So defaults, desktop shortcut, and it's okay. All right. Okay. So once you have finished downloading and installing, you can find it as our the version I installed is 4.4.1. So you can just search, or if you have it on the desktop, you can run it from there. Let's run this one. So when you run the R programming software, so you'll get an interface like this, where it is a kind of like a CMD, similarly to what you use in database system or database programming. If you have done that, you can type anything here and it will give you output in the console as well. And for in situations where you're doing visualization, it will create a new tab on the right side and it will give you the visualization, maybe histogram, or GIF, or whatever you're trying to visualize or output as a graph. Firstly, let's talk about some very, very basic things about R before going into the more advanced things that you are going to use in your assignments. Not advanced, those are also very basics. All right. Firstly, you can use R as a calculator. Okay, so if you write 4 plus 5, it will give you the output as whatever the addition is. Okay, so you can do addition, subtraction, like 10 minus 5, so on. Next one is you can assign any numbers to a value. Let's say A, we assign it as 5, okay, and B, we assign it as 5 also. So you can say A plus B, then you'll get 10, which is the addition of A plus B. You can also use some programming terms like sum. So I think it's sum A plus B, I think something like this. Yeah, it also works like that. And you can also add multiple values to a single variable. Like for example, here I assign number 5 to A, but let's say you want to assign a vector of like 5, 10, 15, 20, 4 numbers to A. How we do that is we do A and then we do the same symbol. Then we use the word C for describing concatenate. Okay, then we can say 10, 5. Let's see if it works. A. Okay. So A right now has two values. All right. We use the C to add multiple values to a variable. Why is this important? Because when you obviously when you do the statistical analysis or any value analysis, you will have multiple values in uh, a single variable, right? So that's why this vector assignment or concatenation is very important. I think yeah, plus minus some basic, and you can do mean, mode, median as well. I think mean A. Let's see. Yeah, so mean A means the average. So 10 plus 5 divided by 2, 7.5. You can do mod A as well, but mod will come out. Sorry, I think mod A will come out as now. Okay, mod. I think. Sorry, mode, right? Mode A. Okay, mode A is not also available. Let's see the last try. Okay, mode A, it says numeric because there's no actually mode. And yeah, as you can see, the capital letters actually matters. You have to write it in smaller letters. Mean, mode, what else we have? Median A. Let's see if it works. Okay, median is also 7.5 because there's only two digits, right? So yeah, you can do some basic statistical analysis with this, but our more focus should be on how to do visualizations, because this will be part of your assignment, one of the assignments where you have multiple visualizations, as well as in your final project you can use R to visualize, to to show that you are utilizing the R programming that is taught in this project to you know maybe hopefully get more marks, right? Let's go ahead with that one. I am not going to type the codes here for the graphs or visualizations because it will take some time, and I want to keep this video short so that you guys don't get bored. And once you review it, you can easily I will give you the file as well, so you can also do copy and paste. And there are some specific values you can change based on your own preference. I will also show them to you. This is just that's why I did the coding beforehand, so that I can make the video shorter and you guys can refer it back easily whenever you have assignment. And this file will also be shared in the classroom, where I have the codes for each of the visualization, and each of this line is explained here of like what is the meaning of that line. If you are too how to say, if you don't like watching videos, or you get bored and you understand better without audio recording, you understand better when you read a document, which is why I have actually created this whole document with explanation of each of the symbols or the functions that I'm calling. You can go through this, and yeah, also you can copy the course from here as well. So let's get ahead with uh, this work. Firstly, we need some kind of data for visualization, right? Let's go ahead and look for a sample data. All right, for today's session, we're going to use the data text file where I have these datas like 248, 348, 74514, just this numeric data as data docs text. Firstly, let's go ahead, as we showed before, how we assign data to a variable is with this symbol. And let's just go ahead and copy this one. Okay. So firstly, I'm assigning the value to data. Data is a variable that I named. It can be anything. Then I'm setting the conversion as numeric. Okay. So if, let's say, the data file has some spaces or something that is not a numeric, it might take it as a string, right? Even though you have it in numeric. So that's why I'm specifying that as dot numeric. Whatever you scan should be a numeric, and then scan and the file location. So for the file location, be aware of the slashes, right? Usually we have, I think, backslashes when you go to properties, and this one is just a normal slash. Okay, so if you copy it, you have to change the slashes to normal slashes instead of backslashes. So let's go ahead, press enter. So it says read 25 items. If we go back to the data set or the data file, we have 25 items here. Let's say we want to print this one and try to see. So if you type data or call the variable, you will see all the data that has been loaded into this variable. Now, for our session today, we're gonna do 4 different types of visualization. Okay, firstly, we're gonna do histogram, followed by frequency polygon, then I think OGIFs, and lastly bar plot and stem and leaf. I'm not sure if stem and leaf has been covered in the class already, but if it's not covered, it's okay. You can like go through the theory later on. We will do the visualization for today. Okay, so for histogram, it's very straightforward. You just type HIST, which is short for histogram, and this is a function. Then you say which data to use to create this histogram. So for our case, we named it as data, so we're going to use data. Then X label, the number of murderers. Then main, murders in selected cities. What main means is the main title of your visualization. So let's press enter and see. So here we can see that the main is the murderers in selected cities, the name of your visualization. Then we have the X label, which is number of murderers, and Y label is by default frequency. You can add if you want a different Y label. From here, we will change a few things. Firstly, you see there is a gap from the X-axis to the actual data, right? And also Y-axis to the actual data, and Y, all the values of Y is, how to say, it's perpendicular, I think, or parallel. I'm not sure which word to use, but it's sideways. All right. So we want it like similar like x-axis as straight. So if we want that, we're going to use this function where we are setting, we are removing the gap on the x-axis, and we're setting these numbers as straight. So if we hit enter, and then also one more thing, if you do the up and down arrow key on your keyboard, it will work as CMD as well. It will bring back your last command. If we now call the histogram again, and this one, this value setting is done once every session. All right. So once you set it, from now on, everything you do or all the commands that you run, it will have this value set. So you don't have to write it every time. So if we set it now, you see the numbers on the y-axis are straight now, and the gap that we had on the x-axis is gone. And then what we have is, okay, this one is the same one. Okay, here this is just a visual modification of same code. If we run this, we are just changing the color to green and the border to white, and the rest of the prompts are the same. Okay, so you can change however whatever color you want based on your own preference. Okay, and then I think this is a histogram. I think you can in the main part you can say that it is a histogram, but it's optional. You don't always need to say it's a histogram or not, because people can actually see and figure out it's a histogram. Okay. And following that, the next one we'll go ahead with frequency polygon. So for frequency polygon, we need a few values. So firstly, we need the midpoints. Okay. And then we need the frequencies. To calculate that, let's first, okay, so this one is, I think, yeah, it's the same thing, same data, but it is doing another scan, because let's say you didn't create this one. So whatever we have, it's gone. So we are starting from the beginning. In that case, I think what it says is, oh, okay, so you need yeah, okay, you need the file location, obviously. I think I'll just copy the previous one. All right, and set the name as murder. Okay, so I have created another variable called murders, but this one has the same exact data set. But you get the point. You can have multiple data sets, because I'm going to create a frequency polygon now. All right. Firstly, we will draw a histogram of the new variable that we created, histogram of murders. Okay, we created that. Then this is just a color change. I think we just skip that line and go to this one. Here what I'm doing is I'm creating another variable called h, and I'm assigning the histogram to that variable. Why is that? Because we want to do some calculations from this histogram, which is why I am assigning a value to it. Then here we have the MP, which is the midpoints. So here I'm saying that the midpoints is a vector. It can have multiple midpoints. Okay. And then we also need frequency. So frequency, here I'm counting the H. H here is the histogram, right? Okay. Now we have the midpoint, we have the frequency. Now let's go ahead with the frequency polygon line. Okay, nice. So we have the frequency polygon line here. So this is connecting every midpoint of the histogram, right? And this is our frequency polygon. Done. But usually, when you see the frequency polygon, it sometimes starts from 0 and ends on 0 as well, right? But here, because we don't have the range, like it is starting from 0 and ending at 600. That's our, how to say, that's our range of the data. We cannot go to 0, or we cannot connect to the end. To solve that, let's change the range of the histogram first. How we change that? Like this. Let's just copy. H is equal to histogram, then murders is our data, and then X limit, C negative 200. All right, so it will start from negative 200. Then max my data 1. I think it's, you have to change it to not my data 1 will not work. This one is murders, right? And then, so the first data is negative 200. The next data is max murders, or in our case is 600 plus 200. So whatever the max data is plus 200. And the color will be green, let's say. Okay, so now our histogram has changed. Now here we have the area negative 200 on the left side and plus 200 on the right side. Now following that, now as we have changed the actual range of our histogram, we have to reassign our midpoints. Okay, let's assign our midpoints. Okay, here the midpoints, like previously we just said the histogram midpoints, right? But now we have like empty spaces on right and left, so we have to add three different midpoint sets. I think that one is just setting it out, and this one. All right. So here, as you can see in the midpoint, the concatenate, and we have the last point is the difference of the first two points, the midpoint difference. Okay, so minimum midpoint minus minimum h midpoint 2 minus h midpoint 1. So the difference we are subtracting it from that. Then we have the h mids, the midpoints of all the points that we have on the histogram, and finally the h mids, the max h mid, all right, plus h mid 2 minus h mid 1, the same difference. So okay, and for the frequency I'm setting it manually, so I'm setting the first frequency to be 0, then I'm setting the h counts for each of the bars, and then 0 as the final frequency. If we go ahead with this one line, let's go ahead. Okay, so now you can see that it is connecting to the end, and what I was talking about is the difference between this point and the point here, and the point here and the point here. That's what we set in this line. Okay, not the difference like this from this point to this point. So this line is big, then this line is small, then this is more smaller, right? Not that one. Difference between this 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 every midpoint difference. All right. And okay, so that's our frequency polygon. Let's see this last one. This is just the plot, I think. Yeah. Okay. So if you want to not have what how to say the histogram, and you just want the standalone frequency polygon, you can use plot. Then you give the MP. MP is the midpoint that we created here. Then we have the frequency, right? Frequency 0, H counts 0 again. Then we have the type B. Type B is the type of design for the frequency diagram. Then we have patch 20, color red. Sorry, not this one, this one, color blue, LW, I think it's line width 3. All right, and then the label, number of murders, Y label is frequency, and the main name of the visualization is frequency polygon. You can directly I think you can directly do this instead of creating histogram one by one, but for calculating the midpoints and frequency you need the histogram, right? This is one way. There might be other ways or other better ways or easier ways you can do this code, that you have that you have to explore yourself. This is a simple way that I'm showing. You can follow this, or of course you can do your own research and maybe you can make something better than this possibly. Okay, that ends our part as frequency polygon. Now let's start with OGIF. Here, this is what it's doing is scanning. We already have the scan, right? Let's just say h break, say h breaks. Okay, this is calculating the breaks of our data set, and then we do counts. Okay, the counts, and then we have murders. Ch breaks with setting the variable values. We have cumulative frequency equals C the summation of each counts. Okay, the cumulative summation, yeah, CUM SUM, sorry, the cumulative summation for OGIF, right? And then cumulative frequency. Before we did all of these steps, right, we add the frequency, uh, but here for this one we need the cumulative frequency instead, for OGIF, right? I think what is this one doing? Cumulative frequency. So here, as we did the cumulative frequency, we started from the data that we had, right? The cumulative H counts and cumulative frequency. So here I'm just double, for assurance, I'm setting the first frequency to be 0, all right? So that we have the so that the OGIF starts from 0, okay? And then it continues with the cumulative frequency. Let's go ahead and plot this one. All right. So as you can see, this is the cumulative frequency. I think you can change. Not think. I'm sure that you can change the labels of y and x and so on. So why did we set this to 0? So that the graph starts from 0. On to the next one. We have finished the OGIF, and the last one is bar plot. This is a straightforward. The bar plot is very, how to say, just a single command line code. All right. If we say that's my data one, not no, right? We have to say, what do you call it? Murders, murders, right? With the capital M, I think. Okay, so this is our bar plot actually. So we have 0, and then from 100. I think here we don't need the 0, right? I think we have to reset the values. Let's just assign a new one. Let's just assign a new data. I think we just say data 1 here. No, not here. Data 1 here. And then we run this code as data 1. Date, sorry, that's a small letter, data 1. Yeah, so this is our unfiltered bar plot, okay? Without any of the constraints that we added so far. What else do we have? We have the bar plots. I think that's all you need for the assignments. They're gonna ask you. And I think one more thing is Steam and Leaf. Yeah, yeah, Steam. So this one, Steam, you just call whichever stem. You call whichever data you want. Maybe murders. I think. Okay, stem, capital letter. Okay. So this is your stem, and your leaf. All right. That will conclude today's lesson for art. If you have any questions, or if the assignments have like something that I have not covered, I will try to show it to you guys next week. If the instruction of the assignments using R is out, please, anyone can send it to me. That will help me a lot. I will try to solve that and share it with you guys on how we can do it. But I think this actually covers all of the codes that you need for your project as well as for your assignment. But yeah, let's see. I will be uploading this file, the Word file, to for your explanation, for you to understand the explanations better. And this is the code explanation video. So that will be all for today. Thank you very much for watching. If you have any questions, you can give me a text in Telegram or WhatsApp, or you can just come up to me in class and ask. So thank you very much for watching. Assalamu alaikum warahmatullahi wabarakatuh.